So up to now, all of the comparisons we've been doing have been focusing on number types. But there is another type we want to learn to work with a little bit before we actually get into conditionals. And that is a type related to the string type. So before we've said that you can have a string and you have these quotes that say this is some text, right? And all of your text has to live between these two sets of quotes. Now in programming, we tend to call these double quotes because the standard quote symbol has the two tick marks. And so we can actually take two strings and we can say this is some other text. And we can say, are they the same? Other. And then I can print that. So this should tell us if they are the same. So I have, this is some text, this is some other text. So obviously they're not the same. And when we run, we get false. Now I can change this to this is some text and make them exactly the same now. And hopefully we get true. Here's where the issue comes up. It is possible to write some legal code with strings. Okay, so now notice these two lines are exactly the same. So we should get our same is true. When I run this code, we actually get false, even though those are exactly the same. This is a topic that we're not ready to talk about yet, but it is something important to note. For strings, we want to avoid equal and avoid not equal. The greater than, less than, greater than, equal to, less than, or equal to. The other four comparisons don't work with strings at all. But these two comparisons are legal. You can actually use them in code, but they don't always act like you want them to. As we can see here, this is a case where it looks like they should work, but they don't. So for strings, we want to avoid that. Instead, we want to use the dot equals method. And the way we do that is we just say my string dot equals the other string. And so if I run this code, okay, I get an exception, and that's probably because I forgot a semicolon. Okay, so we'll put that back. Very easy to forget. Run it. And now they are equal. And if I reverse the order, if I say that other equals my string, and we run it, and it's true. And if I changed it to some other text and run it, it's false. So for strings, which are these things in double quotes here, we can't use equal. We don't want to use not equal. We just need to use dot equals. And the way we do it is it's first string, dot equals, and then in the parentheses we put the other string. It'll give us a Boolean just like before, and most of the time it'll work out fine. There are some cases where it runs into problems, but that is something for us to address when we start talking more about object-oriented programming. So that's something to be careful of for strings. But there is another kind of text that we can work with. We've looked at strings, which are these sequences of text between double quotes. So strings, remember, have double quotes around them. There's another type that we haven't talked about before, and it's called a char or a char, and it's just short for character. And a character is different from a string in that it uses apostrophes or single quotes. And so a character is just what it sounds like. It is one individual character. And I can say other character and get B. And characters are very easy to work with. You can work with them pretty much just like you work with numbers, because deep under the hood in several programming languages, they are the same as a number. So I can actually compare them using all 6 comparisons. And it is perfectly legal to compare them this way. So I can say my character is less than other character. Is A less than B? So in character comparisons, less than means comes before. Does A come before B? Yes, that's true, so I should expect to see true. I do get true. Does A, so is my character greater than other character? So let's make some notes here for the char type. So greater than, so less than means comes before. Greater than means comes after. Does A come after B? Well, that's false. Okay, so that makes sense. Equal is, are they the same? So are these two equal? Is A equal to B? No, so we should see false here. And that is false. Then we have not equal are not the same. And so we can test this one, and we should get that is true because they are not the same, and it's true. And then you might expect less than or equal is comes before or are the same, and greater than or equal to is comes after or are the same. So let's look at the comes before. So one of the things we gotta be careful with is because the letters are actually represented by numbers under the hood. So for example, I could put a capital A here instead of lowercase a. Does capital A come before B? And if we run this, it says true. Okay, that makes sense. Does capital A come before capital B? It does, that makes sense. Does lowercase a come before capital B? It does not, and let's see why that is. So a quick and easy way to look at all these is we're going to print some lines, system.out.println, and I'm just going to put in some values here. Let's see if we like this. Okay, I need to change this to a string, and then we should be good to go here. Okay, so I'll do 4 of these lines so we can see it. And all I'm doing here is changing it so that we print out the number that goes with the letter under the hood. So if I run all these, lowercase a is 97, lowercase b is 98, but capital A is 65 and capital B is 66. So little a does come before little b, big A does come before big B, big A does come before little b, but little a does not come before big B. So it's not saying do these letters come before or after each other in the alphabet. It's saying do they come before or after each other in terms of the encoding scheme. And an encoding scheme is just a method of assigning a number value to a symbol. And I say to a symbol because letters A and B are not the only characters you can print. You can also print the character 1. Now, this is important to note. When I write 1 like this, it's a character. It is a symbol that represents the symbol 1. it is not the number 1, it is the symbol 1. Just like how when you look on your keyboard, you see a key for 1, but that key doesn't really represent the physical number 1. It is just a symbol to write a 1. So it's a subtle difference, but it takes some getting used to. And we run this, we see that 1 has the value 49. 9 has the value, if you want to take a guess, now's the time, 57. So every symbol is going to have a value associated with it. And it's not just letters and numbers like the @ sign. The @ sign has a value associated with it. Okay, it's 64. So when you're comparing characters, you can use all 6 of these operations. But just remember that it means that does this symbol come before this other symbol in a list. Now, Java uses a UTF encoding, but the first 127, first 100, and 127 to 255, depending on what you're using, characters in a table are actually the ASCII table. And so I'll move that over here on screen so that you can see it. And this shows the ordering. We said, for example, let's see. And this is just straight from Wikipedia. Here's the number 1, and the number 1 has the value 49. Just like we said, the value capital A, the letter capital A, has the value 65. We can scroll over and see that lowercase a has the value 97. So this gives you the total ordering. There's some special characters over here. All these ones that are in this greenish color with the brackets are blank characters. They don't actually print anything to the screen. Then you have all your symbols here, then all your digits, then another batch of symbols, then all your capital letters, then another batch of symbols, then your lowercase letters, then another batch of symbols, and then another blank character. So these are the first 127 characters, or sorry, 128 characters in the ASCII table, which is just one encoding scheme. So if you're ever working with characters, remember, we're not saying are the letters the same, we're not saying are the numbers the same, we're saying how does the under the hood, the ordering value compare. Lowercase a comes before lowercase b, capital A comes before capital B, capital A comes before lowercase b, but capital B does not come after lowercase a. And that is all based on the encoding table. And so this is something kind of you need to get used to, but this is a way of writing individual characters. So if a string is double quotes, a char is single quotes, which is just the 2 apostrophes, and the only difference is they can only hold one symbol. Whereas strings can hold many symbols. So if I were to try to put in another letter here, Java would complain at me because a character can only hold one letter. Some languages allow you to have an empty character. Java doesn't like that, but I could put a space, and that's okay as a character. In fact, if you look at the ASCII table, we can scroll through here briefly. There we go, space. Should have decimal value 22. And so if I wanted to check that, then I just need to go like this. I can run my code. And space does have the value 32. And so in order to figure out what these values are, you just need to put int in parentheses followed by your character. So if I wanted to simplify this to just work for any symbol, I really could say just int followed by my character and run the code and get 32. So the takeaways here are how to work with the char or char data type. It's a primitive type. It's very simple, just like the ints and the doubles and the booleans, and how all of the comparisons do work with it. So it's definitely worthwhile getting some practice with the char data type or the char data type. And then remember with strings, our big takeaway was that we don't really want to use the equal, equal, and not equal. And the other comparisons, which include less than, greater than, less than, equal to, and greater than, equal to, do not work at all. But the equal, equal, and not equal only work sometimes. So for strings, we should definitely use the equals method, and then we should treat the chars using these rules, remembering that it's not saying the letter comes before another letter. It's saying that does this symbol come before or after a different symbol in the encoding table. And for us, the encoding table for our basic symbols is going to be the ASCII table, even though Java uses a more advanced encoding table. It does base it off of the ASCII table for these characters. But that is going to wrap us up on comparisons for strings and characters, and so this is something that we can use going forward in our next lessons on conditionals.